Okay, this is analytic geometry again for grade 10 mathematics, although again, grade 9s will find this useful. First thing we're looking at here is equation of a circle, and again it's Pythagoras, where the equation comes from. You remember Pythagoras' formula where square the sides around the right angle and add them together, and that will be the long side, the hypotenuse squared. You can actually find the long side by saying it's the square root of the other side squared. Equation of a circle uses exactly that. If you look at this triangle I've drawn here, this is the length, this is the height here, and if you were to apply Pythagoras to that, use that length and height, what you would be finding would be this hypotenuse along here. That hypotenuse is the radius in a circle. So you can see the radius is just the x squared plus the y squared. I mean, if you can look here, it's x minus 0 squared and y minus 0 squared because you've started at 0, 0. But essentially x squared plus y squared. Alright, so if the way to find the radius is like the hypotenuse of a triangle, square root the height and the width squared, you can square both sides of the formula and you get the equation of a circle. R squared is r squared, and if you square the right side you cancel out the root, so you're just left with x squared plus y squared. This is actually the equation of a circle that is centered on the origin 0, 0, and that's all you're going to work with in grade 10 is circles that sit right on 0, 0. So essentially the equation of any circle is x squared plus y squared equals the radius squared. So for instance, if the circle we were looking at was in this case radius 3, well, because the radius is 3, we would say that the equation of this particular circle would be 3 squared equals x squared plus y squared, or if you like, x squared plus y squared equals 9 then. That is the equation of this particular circle. Let's look at perpendicular bisector of a line. Now this is using the theory that you've gotten earlier from slope of a line. So I'm using the same points we used earlier, right? I'm using line segment AB, I'm using midpoint C. Now essentially what I'm going to do is just use slope of the line and midpoint C, that's it. So first of all, slope. Well, the perpendicular slope is at a right angle to the regular slope that you found, slope AB. So before we found slope was a half. That's the slope of line segment AB. So I'm going to do minus 1 over a half. That's how you find the perpendicular slope. Minus 1 over a half gives you minus 2. Another way to think of it is you basically just turn the fraction upside down and change the positive or negative sign. So if you turn a half upside down and change the positive or negative sign, you get negative 2. Okay, so negative 2 is the slope. We are going to use midpoint C for 3. So here I have just got the equation of the line is y equals mx plus b. You can see I've got y equals minus 2x plus b. I put slope minus 2 in. Then I substitute the point y is 3, x is 4 into that formula. I find b is 11. Again, that's 3. Bring the minus 8 to the other side, gives you 11. The equation of the perpendicular bisector is minus 2x plus 11. So that dotted line will eventually go through 11. You can graphically confirm that if you like. And it has a slope of negative 2. Whereas if you look at line AB, that has an intercept of 1 and has a slope of a half. That's perpendicular bisector of the line. Okay, and all this analytic geometry you've been doing, you can use it to confirm geometric properties of shapes. For instance, you know how to find the slope of lines now. Well, you could find the slope of this line and show that they're equal. You could find the slope of this line and this line. You can do that for any rectangular shape or parallelogram. And if you prove that slopes are parallel, you're proving that this is, for instance, a rectangle if the slopes are parallel, and you prove that those lines are perpendicular, then you've proved that that is indeed a rectangle. You would also have to prove that the sides are equal length. So let's look at if we had to prove that this really was a rectangle. We would say, first of all, are those sides there and there really parallel? We'd also have to say, what about these sides here? Are these at right angles to each other? We could actually just find the slopes of those sides and say, do they multiply to make minus 1? If they do, they're perpendicular. And then we could use Pythagoras' formula to find the length of these lines. And that would be enough. You can also, for instance, apply all that theory to triangles. Here you've got an isosceles triangle here, so look, you could use the Pythagoras formula, and you could find the lengths of these lines, and show that the lengths of those lines are equal. If they are, you've got an isosceles triangle. Or here you've got a right triangle. Again, all you need to do is show that that is perpendicular to that. So again, you would just say, like, find the slope of one line and the slope of the other line, and if they multiply to make -1, I know that I've got perpendicularity. Okay.